Okay, so I'm going to go ahead and go over the tutorial for your assembly. Now, to begin with, in your C drive, you should have the installation inside the Irvine folder there. I believe the one that I gave you will work for Visual Studios 2012 as well as 2013, which is the one that I have on this computer. There's a different way to do the 2015. That one is an installation. They have a tutorial there in the website. But for those of you who have 2012, you have Irvine. It should be directly in the C drive. It's going to have an examples folder. And you should open the project sample. Well, actually, don't open it. You're going to copy and paste on the desktop. And that's it. Do not modify any files in there. This here, I'm going to name it whatever homework it was. I believe this one is homework 4. So now that I call it homework 4, I'm able to modify it. The other homeworks, you're going to create different folders. They are all copies of that project sample. I'm going to go ahead and open up the Visual Studio for it. Now this one here is the 2012 edition, so I just went ahead and updated it. It basically did this change in platform, and you're going to notice this is what it comes with. If you try to run this, it'll give you assembly language program example. As you can see, it's exactly what it says here. I'm going to go ahead and change this. And actually, let me just make this bigger so you guys can see better. If I change that to Hello World and run that, Hello World. Okay, so that's a simple Hello World program. Now we need to see what exactly is involved in here. Specifically, I'm going to start from the data section. Everything from the .data to the .code in between is where you're going to declare variables. All the actual code is going to be between the main proc and the main NP. Okay, proc NP, we're going to explain what that is in a later date. For now, this piece of code here is our main program. First thing it does, call CLRSCR. Now this is not case sensitive. You can have it as lowercase if you would like. CLRSCR is clear screen. So it's not really needed in the beginning, but if you put it there, I mean, it doesn't hurt. This section here, move EDX offset of my message, which my message is this. Once again, it doesn't matter. It's not case sensitive, so even though this is lowercase and this is uppercase, it's talking about this one. It's going to move its address into EDX so that it could know to output this once it does the call write string. Now, every single time you're going to work with any form of messages or going into the screen, such as using the write string, you're going to have to put it inside EDX. EDX is a special register meant specifically for strings, output of strings. Okay, so another thing that we have is the ability to get an integer, and if we could do something like write string, we should have the ability to read string as well as write int and read int. So I'm going to see what read int would do. Now I can't simply call read int because this here says it's calling the write string. So if you just put read int, it's not really doing anything. You have to call it. In a later chapter we explain what call does, but it's basically calling a different action. So Okay, so we have call read int. Let's see if the program runs just with that. And now notice that it's just waiting. So call read int is somewhat our C++ version of cin. Okay, we're trying to cin an int. So if I put 7, then it continues with the rest of the program, which is move my message into EDX and write string. Comments are with a semicolon, which is weird. If you try to put the 2 forward, it's not going to work. It's the semicolon, and this call write string will display anything in EDX. Now, when it displays something in EDX, it has to be the offset of the string. So the starting location of the string, so it knows how to display. Now, magically, we did a cin. Where was it saved? In C++, we have to cin into a variable. Well, here it's not being saved inside a variable. It's being saved inside EAX. EAX is a special register when using integers. Any single time you read int, it's going to go into EAX. Okay, so just to mirror what you just typed in, I'm going to call write int. Let's see if it mirrors what we just typed. 9 plus 9, hello world. So the plus 9 just means it's a positive number. Remember your first assignment, we do have positive, negative numbers, so it displays its sign. Okay, so this is working. Unfortunately, it didn't leave some space between the int that you just displayed and the next message. So that's perfectly fine. We'll get to that in a later chapter, or quite possibly in this tutorial here. But this here was just to mirror what you typed in. What if the next command was call read int again, followed by call write int? Right, 5, 5, 7, 7. It's working, but this little space, if you're working with a user, will be very confusing. So we do need to go to the next line in that case, which would be okay, call crlf. As you can see, it goes to the next line, which means that will go to the next line. So as you can see, all these calls and then these words here, it gets extremely difficult to understand. So I would highly recommend you have a form of commenting in order for you to be able to determine which part is which, such as possibly separating into different sections of code. So simply coding like this makes the rest of the semester a lot easier. Okay, good. Now, something like this, let's say I wanted to add this first number that I got with this second number that I got. Unfortunately, right when I did call read int, it saves it into EAX. Now, that's exactly what this did. It saves user input in EAX. Well, this one gets a number and saves it into EAX. Well, what happened to this guy? He's gone. So, if you want to keep him, you would have to do something like this. Move. So the move command is so you can move from one to another. And what we are going to do is I'm going to move into EBX, EAX. So EAX is going to move into the EBX. Now, after I input my second number, I have the first number in EBX and then the second number in EAX. So now I'm going to go ahead and add the two numbers, which is as simple as add EAX, EBX. So what this does is it adds EBX and EAX, but it stores the result inside the first one, EAX. Now the reason I wrote it like this is because if I want to call write int will display what's in EAX. So no matter what, if you want to display a number, you have to move that number you want to display into EAX. If I had done something like this, then our sum is saved inside EBX. If you want to display that number, you would have to move the EBX into EAX. And now you can call write int. Let's see how this looks. 9. Okay, those are 9. 10. There's our 10. And then it shows 19. Great. So that's simple stuff, mathematics that you can do. It's the exact same thing with subtract. So if I wanted to subtract, and I run the program, if the first number is 10, the second number is 22, well now the number would be negative 12. Okay, so I start off with 10, the next number is 22, so I subtract 22 from 10. Negative. I don't know if you could see that well. Let's see if I could that's the cursor, font. Ooh. I guess that's better. Alright, sorry about that. Alright, so it's got negative 12 as our answer. So addition, subtraction, if you read through the book, it does seem a little difficult, but it's as simple as this logic here. I will upload this file for you guys. Alright, so my message. This information up here, what exactly does that mean? Okay, we know how to use it because we just have to move the offset into EDX and call write string. That's how to display this information, but what are the contents? Well, my message is the name of the string. Byte is the size of the string. So we are able to work with different sizes. For now, we're working with byte. Inside of quotes, you're going to put the string itself. You can put a long string, a short string, but there is a size limit. And then you have comma 0DH, comma 0AH, comma 0. What exactly does all of that do? Okay, so if I were to erase 0DH and 0AH, leaving it with simply comma 0, this is just 1 minus 1. Notice, hello world, press any key to continue, so the spacing on there is gone. So this section that says here is telling you that it's going to go to the next line. That's basically what it does. One of them says go to the next line. The other one says go to the far left. This comma 0 means you're at the end of the string. Now, if you don't put something like that, and let's say I put a second message, my message 2, I know you. Now if I were to erase all of these, let's see if it compiles. 1, 1. Hello world, I know you. Notice what it did? So my message contains hello world, and that's not the end. So the comma 0 says that's the end. Since it's not there, it's going to continue, and it's going to take my message 2's information until it sees, oh look, comma 0. That's the end of my message. Now, my message displayed both. My message 2, which if I just put a simple 2 here, simply says, I know you. So this is pretty cool how you can separate them. This one contains both. This one only contains one. More than likely, we are just going to work with one of these with the 0AH, 0DH, 0 at the end. Unless it's something like our homework, which has you do a little hello and then their name, then you are, and then their you were born in, I think it's based on the year. You were born in, and then it shows the year. Okay, so all of that has to be in the same line. Well, to keep it in the same line, you simply don't include that. Sorry, you do include one comma. There you go, comma 0. And like that, you're still in the same line. You'd have to start the next one with a space, though, in order for it to be separated. But that's simple stuff you've already learned in your C++ class, how to set up little strings like this when you see out. Okay, so you know how to do some of this part, so I'm going to go ahead and do something like this, to where I am going to type, please enter your name. We don't need numbers, so I'm going to comment out that whole section. We're just going to go straight into displaying the message. So here, oh, I know you. Sorry. That was accidental. Please enter your name. I would assume that if I did the following, it would work correctly. Read string, correct? Somewhat the next thing that comes to mind after seeing this line. Let's find out. Please enter your name, press any key. Well, it's not even letting me type. There's got to be something wrong, right? The answer is you can't simply call read string. You have to set up everything for where it's going to go, quite possibly the size limit that you're allowing. So I'm going to go ahead and it's set to create a variable at the top. So I'm going to call this name, I'll call it name1. It's going to use a byte. Once again, it's not case sensitive, so this one's all capital, this one's a capital B, this one's fully just lowercase. And, well, I don't know what's going to be in there. Let's do this one. So far from what we know, based on this tutorial, that's everything we have. Okay, so let's go ahead and move into the EDX, the offset of, was it name1? Was it name1? Now will it work? Let's find out. No. Well, in reality, you need to tell the computer also how much are you going to type in there. So you need to tell it the size of the destination. So I'm going to do move ECX. Now ECX, usually it's the counter, and since we're talking about how many characters we're going to put in there, it's going to keep a counter of it. The size of name1. What is it going to do now? Okay, so at least it's giving us the ability to type in a name. Press any key to continue. Did it actually work? Well, let's find out. Right now, what's inside EDX? The offset of name1. So if I were to do, would that display the contents of name1? Let's find out. Nick, yay. Okay, so we've got strings. Unfortunately, we had to create a variable that has something else here. Notice what happens if I just call it he. Okay. Notice what happens if I just do that. Okay, so you can't have a null. In reality, this is not how you set these up. These are very badly made. Sam. You can create variables like this. I believe in the first few chapters, this is all they talk about, how to do these messages. So you may not know the actual way to write these, which in reality you use string format, something like that. But for now, we're not going to go into those. We're just going to go ahead and create something with this type of format. That's perfectly fine. It does look silly, but it's working. And once we get to later chapters, we'll start doing the correct way. There's also this other method. Let's commenting that. Name one byte question mark. I have no idea. That's basically what you're saying. Let's find out what type of comment the test, press any key to continue. Okay, so right here I have no idea, there's no size in there specifically, so it's giving you nothing. Later on we'll be working with this type of data, changing it up to where we have better use of this. For now, yeah, you could keep it like this. So go ahead and compile it again. Okay, I need to do for you to be able to see the next part correctly. Samantha. Sam. Wow, this computer's so good. It abbreviated, it made a smaller name. No. This is always going to be the case. No matter how big of a string you type in. Geo. It's only doing 3. Now, let's see if it has anything to do with this. If I change it to 2, Samantha. Samantha-sama. Okay, so now it did 4, so it has a direct correlation to how many characters you have here. That's what I was talking about before. Later on, we're going to be able to say the size of it, but since we don't know the size of it, it's best you just need to create a huge string so that whenever they type something, it'll accept it. That's allowed for now. Just be aware that this is just a completely inefficient way to do this. Later on, I will cover the efficient way. Alright, so if you've gotten this far, that's great. You know how to get a string. So here I have the string. Next I need to ask for their age. Get the name from the user. I do not need this section here. I just have to get that. Next I need to ask for the age. Okay, so display message on the screen should actually be let's see if that compiles. Okay, so everything is looking good. Here, when we ask for the person's age, I'm going to call readInt. This here, sorry, this thing will get the person's age and store it in EAX. Good. So the next part of your program was displaying something. I'm going to go ahead and somewhat give you a bit of that. Okay, so this is something that we did not do. Ask them for their age. I did directly get the age. Now, if you're familiar with C++, I do get a lot of students that simply expect the user to know exactly what the computer wants. In here, after they get the name, it would be polite to be asking the age. So actually this is here, this is not asking for the age, this is getting the age. Okay, so to ask for the age, I am going to call read string, right? I waited for a little while to see if you guys are just waiting there, just simply saying, no. Okay, so if you know my teaching style, here I directed you falsely into the wrong place. It's asking for the user's age, but in reality, you're displaying this message, which is an outward message. So this outward message is a write string, but before you write the string, you have to make sure that you put inside edx what you're going to display, which in this case is my message 2. So now you have my message 2, call write string, and then you get the integer from the user. Okay. Without making it look pretty, I am going to do another call CRF. I am going to display both the name and the age they just typed in. So I think it's already name 1. No, never mind. Move EPX offset name 1. We're only going to display. We're not inputting to the computer. So to simply display, you only need the offset. You do not get the size up. This is only whenever you're going to read. So I'm going to go ahead and write string. Go to the next line. And call write int. Go to the next line. Nick, well, let's say I'm 22. Nick plus 22. That's good. Now you need to make it look somewhat pretty, right? So I'm going to create more variables again. And let's say greeting 1. And let's just say hello, space, and then I'm going to say their name. So simply comma 0 to make sure I stay in the same line. The second one, after they type in their name, it's a comma. You are. Then I'm going to say their age. Space. Years old. 0 DH, 0 age, 0. So that's the end of the sentence. Now, simply doing this one little hello, Nick, you are 22 years old, is going to take these 3 variables here. Okay, so this was the greeting right here. I'm going to go ahead and add the content. So this whole section is the greeting. Okay, so this right here says the hello. Then the name 1, their name. Next. The greeting 2. Okay. Next, we don't want this CRLF. We want to display the int. Okay. And finally, we have this portion here. Let's see how this looks. Hello, Nick, you are plus 22. years old. I don't know if I left a little space after R. I'm going to have to check into that, but this is how you would do a greeting. Now, I know your homework says to get their name, do a little greeting, but instead of showing the age, you're going to say what year they're born. So the math you are going to do is simply the year 2016 minus their age would give you the year that they're born, somewhat. How would you subtract something like the year 2016? If you do something like this, I'm going to go ahead and call write int. I'm going to subtract from EAX 4. As you can see, it's subtracted. So if you start off with a certain number, 2016 for example, and then you subtract their age, which is located inside EAX, you could somewhat get the year they're born. Now this can get somewhat confusing. If you wanted to move the number 2016 into one of these special registers, here we added the 2016 inside the EBX. Sorry, not added, we moved. So now EBX contains 2016. Removing this subtraction, we know that EAX has their age, so if you subtracted, okay, I'm not going to give too much hint on that. I'm almost doing the homework for you guys. So at this point, I do believe we cover everything required for homework 1. If this seems confusing, you should look at the book. Once again, it's the chapters provided to you on there. If you have any questions, please email me, and you have till Wednesday to turn in the assignment. Okay, thank you.